Hello everyone. So in this segment, we're going to talk about the partitioning strategy. All right. So in the quicksort algorithm, how we can do the partitioning. So in the partitioning, we're going to find all the elements that are less than pivot, and that will be at the left of the pivot. And all the elements that are greater than or equal to pivot is going to be placed at the right of pivot. So let's say this is our array. All right, so we have a couple of elements in the array, and we're going to pick a pivot first. So let's see, our pivot is 10. Okay, we haven't talked about how to pick a pivot, so there are also multiple strategy we can follow that, but let's just see, we are picking any element as a pivot, and around that we are going to partition the array into two part. Okay, so here our pivot is P, and P is 10. Okay, so this is our pivot element. So the first step is that we are going to move the pivot out of the way. Okay, so that's why what actually we're going to do, we're going to swap pivot with the last element. Okay, which is 22. So 22 will be here and 10 will be here. So what actually we are doing, we are moving the pivot at the last of the array so that we can continue with the rest of the element in the array. Okay, so our array will now look like 5, 1, 3, 22, 15, 4, 1, 25, and 95. Okay. All right. All right. Now let's talk about the partition. And in the partition, we're going to actually consider only this part of the array. Okay, because this is our pivot. So we'll have two index I and j. All right. So we're going to use two index I and j. I is going to move from left to right, start from the index 0, and it is going to move from left to right. And j will start from this index, okay, next to the right element actually, and starting from here, it is going to move from right to left. So again, reminding you again, if P is the pivot element, at the left of P, we are going to have all the elements that are less than P, and at the right of P, we're going to have all the elements that are greater than or equal to P. So J is going to find all the elements that are less than P. Okay, so at the right of pivot, we have to have all the elements that are greater than P. So J is going to actually move from right to left, and if he finds any item that is greater than P, means it's fine. But if J finds any item which is less than P, okay, now it knows that if a item is less than 10, means it is going to move that item at the left side of the array. Okay, same for I. At the left of this array, all the elements should be actually less than pivot. Okay, so now if I find say element which is less than pivot, means actually it's fine, it's in the correct place. But while traversing, if it finds some item which is greater than pivot, means now it will see if it can move this item at the right side of the array. Okay, so we are going to find actually couple of cases. Case 1, while traversing I and j, there we are going to find couple of cases. Case I is that, let's see, we find AI. This is our array A. All right, so array AI is less than pivot, and AJ is greater than pivot. Okay, so I start from here, J start from here. So what does this condition say? These conditions say that in this stage, when AI is less than pivot and AJ is greater than pivot, they both of these numbers actually they are in the correct place. Okay, it should be, this number should be actually in the right side, and this number should be actually in the left side. They are at the correct place. So in this case, we don't have to actually do anything okay special. What actually we are going to do, we are going to just move I and move j. So we are going to move I left to right, so I plus plus, and we are going to move j left to right, right to left, so j minus minus. So here you can see that 5 is less than 10, 95 is greater than 10. So they are actually already in the correct place. So don't do anything, just move I and j. Okay. So I will be here and j will be here. Okay. Now let me just erase the old I and old j. Okay. So now case 2. Case 2 can be, let's see, AI is greater than or equal to pivot and AJ is also greater than or equal to pivot. Okay. So it means while we are traversing, we are at a position where AI is greater than or equal to pivot and AJ is also greater than or equal to pivot. Okay. So in this case, you can see that 11 is greater than 10 and 25 greater than 10. So this is our case. So we know that if the element is greater than pivot, it should be actually on the right side of the 10. I mean, we should move it at the right side of the array. Okay. Now, what actually we have to do, we are going to actually keep I waiting here. Because actually, if I want to move 11 at the right side, I have to find a place. First of all, I have to find a place. All right. Now, j is pointing a number which is greater than pivot. That means it is at the correct place. Okay. So what actually we are going to do here, we are not going to move I. So we're going to keep I waiting at this point. Okay. And we are going to only move j. So j will be minus minus. Okay. So we're not going to move I, we're going to only move j here. So what does it mean actually? I is actually waiting here. Okay. I is waiting for a correct number for j so that they can swap. All right. All right. Now case 3 will find when AI is greater than equal to P and AJ is less than P. So you can see that AI is greater than or equal to P. I mean, on the left of the array, we have I is pointing a value greater than P. J is pointing a value which is less than P. Okay. Now this is the point we are going to do the swapping. Okay. So you can see that 1 is less than pivot. So 1 should be actually in the left side. And 11 is actually greater than pivot. So 11 should be at the right side. So now this is the case when we are going to do the swapping. So we are going to swap AI with AJ. Okay. So after we do the swapping, it will look like it will be 1, it will be 11. All right. So I'll just mark it here because we did the swapping. All right. So, all right. After we did the swapping, actually, this is the case again. This is the case. Okay, case 1 is now true. So now AI is pointing the value less than P, AJ is pointing the value greater than or equal to P. So means actually again the time to move both I and J. So we're going to move again I, okay, I plus plus, move again J with J minus minus. Okay. So now another case, we can find actually another case. In this case, we can see AI is less than P means correct for I, okay, and but AJ is also less than P, okay. So here, so if AI is less than P, all right, uh, if AI is less than P means AI, that this number is actually at the correct side, but AJ is less than P means this number is not actually at the correct side. It should move actually on the right side. Okay. So what actually we are going to do here, I mean, as we want to move at the right side, but we have to actually wait at this position. So we're going to keep J here waiting. We're going to only move I. Okay, like this, I plus plus. And J is going to wait here until we find a correct position where we can do the swapping. Okay. And the swapping position we are going to find only at this case when AI is greater than or equal to P and AJ is less than P. Okay. So J is going to actually just wait here and we are going to only move I. So I will be here. Okay. Let's erase something so that it becomes more clear. All right. All right, so these are all the case. Now let's see what happens here. So now here we can see that AI is greater than pivot and AJ is less than pivot. Okay, so this is the case again. All right, so this is the case again, case 3. That means we have to do the swapping. Now we can do the swapping. Okay, so let's do the swapping. So it will be 4, it will be 22. Okay. Now, after we did the swapping, you can see that it's actually case 1 because AI is less than P, AJ is greater than or equal to P means it's time to move both of them. Okay, all these numbers are at the correct place, so we're not going to do anything. We're going to only move I and J. So now you can see that I and J both are actually at the pointing the same position. Okay, same index. All right, now okay, so in this case what we can see that what is this case, so AI is greater than pivot and AJ is also greater than or equal to pivot. Okay, so what actually we're going to do, we're going to only move J will be here. Okay, and here we have I. All right, now this is the case actually where we are going to stop. Okay, so you can see that I am moving I from left to right. I'm moving J from right to left. And at some position, we'll see that, okay, we'll see that J will become less than I. And this will be our position when we are going to stop. Okay. So we are going to stop here. And now actually we are going to move the pivot at the correct position. Okay, so remember we moved the pivot at the last of the array so that it gets out of our way. Okay, now we are going to move pivot at our correct position and we are going to do the swapping, okay, with AI, this element with pivot. Okay, we are going to do the swapping like that. AI and pivot means a with the index. Okay, so 10 will be here. Let's use the eraser. So now we're going to make 10 here. We're going to keep 15 here. Now look at our array. So you can see that all the elements here, 5, 1, 3, 4, all of them are less than 10. And all of the items here, they are greater than 10. 22, 11, 25, 95, 15. Okay. So this is the partitioning strategy. We use 2 index I left to right. We use another index J right to left. Okay. So when we find this case means the item is greater than item pointed by I is greater than pivot and item pointed by j is less than pivot, means this is the position when we are going to stop. When we are going to do the swapping. Okay. In every other case, actually we are going to move either both of the index or only one index. Okay, based on the condition. All right. So when the index j is less than I, means actually we are done traversing all the item and we are going to just move the pivot at the correct position and we are going to do the swapping with the position point with the number pointed by I. All right. All right. So now you can see that actually what is the runtime of this algorithm. The runtime of the algorithm is we are having only two index. I is moving from one direction, j is moving from another direction, and that's how we are actually traversing the whole array. All right. So in this partitioning strategy, the runtime is linear, so order of n. All right. So let's see the example we have here in the slide. Okay. So here pivot is 6. In this array, we are choosing pivot 6. So first we are going to actually move the pivot at the last of the array. Okay. So that's why we're going to do the swap between 6 and the last item of the array, 19. Okay. So then what we want to find, we are going to move I and j until we're going to move I and j when I is less than j. But if we find that j is less than I, it means it's time to stop. Okay. So both I and j will stop only the case when ai is greater than or equal to pivot or aj is less than or equal to pivot. Means this is the time when we are going to do the swapping. Okay. For example, here we'll find that 5 and 12. So 5 and 12, actually this is the correct location. We're not going to do anything. We are going to only move I and j. Okay. So we're going to move I, we're going to move j, because this number is less than pivot and this is greater than pivot. Okay. So don't do anything. We're going to just move I and move j. Okay. Now I is pointing 6, j is pointing 3. Okay. So in this case, actually we can we are going to do the swapping because I is pointing a number which is greater than or equal to pivot, j is pointing a number which is less than pivot. So means that this number should be on the left side, this number should be on the right side. Okay. So here we're going to do the swapping between 3 and 6. Okay. So now I is here, j is here. You can see that they are at the correct place. All right. So we're not going to do anything. We're going to just move both I and j. Okay. So I will be here, j will be here. Again, they are actually in the correct place. So don't do anything. We keep moving I and j. At some point, j will be here, I will be here. So this is the point, j less than I. Okay. We know that we have to stop. Okay, means we done with the traversing and we actually moved every number less than pivot on the left, all numbers greater than or equal to pivot at the right. Okay, so then at the end we are going to just move back the pivot at the correct position. Okay, with the index I. Okay, and you can see that all the items are at the correct place. Okay. All right. Now I'm going to talk about how to pick a pivot. Okay, and I'll talk about in the next slide, in the next video.